Okay, in this video, let's talk about section 9.4, area of a triangle. Area of a triangle. Okay, so it's not a new topic, right? So whenever you have a triangle, we know how to compute the area. The area is equal to 1/2 base times the height. Base times the height. The height is the segment from the opposite vertex to the base vertically or orthogonally. All right. So this formula comes from you cut the you add additional triangle, make it like a rectangle, and from the rectangle you get this. Okay, it's not a fresh knowledge. But let's try to add something. For example, this is B. This is H. This is A. This is C. C is here, so this is angle C. H, if we cover the right triangle, you see, this is height. Height actually give us two right triangle, either the right side, either left side or the right side. Right? So let's talk about this side. Left side, you have a right triangle. H is a hypotenuse, so hypotenuse over adjacent A. What did I say? I'm sorry. H is opposite. H is opposite. A is hypotenuse. Opposite over hypotenuse is equal to sine of C. We used this condition in the law of sine. So H is equal to A sine angle C. You plug in here, then we get our second formula. Area is 1/2 B times A sine C. And in the alphabet order, we normally write like area is 1/2 AB sine angle C. See? So in the problem, A and B are the sides, and the angle C is an angle. AB sine C. Okay? By the permutation, for example, if we cover the left-right triangle, we consider the right one. This is A, its opposite angle is here. And then the H is an opposite of A, so H over C hypotenuse. H over C hypotenuse is equal to sine A. So H is C times sine A. So plug in here, we get another formula. Area is 1/2 B times H, B times C sine A. So this is another equivalent formula. Here you see A, side B, angle C. Side B, side C, angle A. And you can expect that the area is also equal to CA sine angle B. Side C, side B, and angle B. So we add 3 new formulas for the area computation. All right, so this is a new formula. For example, let's try it. If we have triangle, let's see what is a triangle. Triangle. Yes. This angle is 30 degrees. This side is 6. The base is 8. And this is angle B. This is angle A. Okay. And this is side C. Find the area K of the triangle for which A is equal to 8, B A is equal to 8, yes, B is equal to 6, and angle C is 30 degrees. And also be careful, you see AB sine C, A and B are two sides of C. If you use BC sine A, B and C are two sides of A. So this kind of a condition requires SAS positions. SAS, side angle side. It has to be side angle side. So the area K is 1/2 AB sine C. So 1/2 is here. A is 8, B is 6. Sine 30 degrees is 1/2, another 1/2. 1/2 times 1/2, 1/4. 8/4 is 2. 2 times 6, 12. Okay. So that's a 12. All right, it's not bad. AB sine C, SAS triangle. When you have SAS triangle, you can determine its area easily. Let's talk about SSS triangle. SSS triangle means we know all three sides. A, B, and C. Can we have a formula to compute the area directly? So this is called the Heron's formula. The Heron's formula says the area K, why they use this letter K? The area K of a triangle with sides A, B, and C is K is equal to S minus A, S minus B, S minus C, this product, and take square root, where S is 1/2 of A plus B and plus C. Okay, so when you get this half of the sum ABC, you put it in the formula. You can compute the area. All right. Let's try it. For example, so find the area of a triangle whose sides are 4, 5, and 7. Okay, so how do we find the area based on those three numbers? First, you compute the S. S is 1/2 of 4 plus 5 plus 7. 4 plus 5 is 9. 9 plus 7 is 16. 16 times 1/2 is 8. S is 8. Then the area is 8. See, then 8 minus 4, 8 minus 5, and 8 minus 7, and take square root. Okay, so 8, the first one. 8 minus 4 is a 4. 8 minus 5 is a 3. 8 minus 7 is a 1. All right, and 8 is a 4 times 2. So you have a 4, okay, 4 times 2 and times 4 times a 3. And you have 2 copies of 4, you move it forward, there's only 1 copy. And 2 times 3 is a 6, so the area is 4 times square root of 6. That is the answer. All right. Very good. So that is the example of the Heron's formula. In this section, this is a very, very short section. In this section, we only introduce two types or two classes of area computation. One is this one, AB sine C. AB sine C. The other one is this Heron's formula. You're supposed to use those formulas to compute the areas and the area. So this is just area of the triangle. We try to give you more formulas. And at the end of this section, they gave the proof of a Heron's formula. That's not required. So if you're interested, you can, the proof of Heron's formula is not required. If you're interested, you can read it, but you don't. I don't test it in the exam. Okay, so we finished this section. It's a very short section. I'm going to later. I'm going to make another short video to discuss some examples. Okay, so we stop this video and we will start with examples.